Good morning, everyone. My name is Jamie. During our presentation, me and my teammate Skylar will introduce the usage of neutralization reaction in the field of both agriculture and industry. In my part, I will focus on soil acidification. By definition, soil acidification is the process which pH value of soil decreases over time. It occurs because of the increasing of concentration of hydrogen ion in the soil. Contributing factors. There are various factors that contribute to soil acidification, such as environmental impact, for example rainfall, and nutrient absorption. The most significant contributor is the excessive use of fertilizers, for example ammonium-based fertilizers, as we can see the picture here. Let's now move to the negative influence. Speaking of this, soil acidification affects agricultural production from different perspectives. First of all, it affects the activity of the soil, causing the soil compaction. As we can see the difference between these two figures, the soil in the left side is less compact than the right side, which means it's good for the plants to grow. The second influence will be it lowers the efficiency of nutrition. Under such a situation, farmers may have to use extra fertilizers to grow the plants, result in wasting fertilizers and polluting the surrounding environment, which my teammate Skylar will introduce this in her topic later. The third point will be inhibit the development of the plant's roots. As we know, roots help a plant to grow and stand. Compacted soil inhibit the development of the plant's roots and leading to the decreasing of the plant's survival rate in extreme weather such as rainstorm and snowstorm. Last but not least, it causes the malnutrition of the plants. The most significant feature would be weakening plants and reducing disease resistance. In addition, soil acidification releases the aluminum ions in the soil. Absorbing too much of these aluminum ions will result in poisoning the plants. Even worse, these poisoned plants may be endanger to human beings through the food chain. As you can see from the figure here. In order to solve this issue, scientists have pointed out some useful solutions. The most common solution is to apply lymph to acid soil which contains sulfate acid. The formula represents the reaction would be this. By adding calcium hydroxide to the soil, the calcium hydroxide and the sulfate acid will undergo a neutralization reaction and producing calcium sulfate and water. Because of the products of this reaction is soil and water, the pH value of the soil will increase. Soil acidification can be released. The solution of this issue may also refer to applied organic fertilizer to balance the pH value of the soil and perform a less acidifying farming practice when soil shows signs of acidification. Thank you for watching, and let us now welcome Skylar to introduce her research on water pollution.
My topic is industrial uses of neutralization reaction. Industrial wastewater is divided into acidic wastewater and alkaline wastewater. Most of the acidic wastewater is from chemical plants, steel mills, and electroplate factory. And most of the alkaline wastewater is from print works, oil refinery, and paper mills. In general, when the acid content is less than 3% to 5%, or alkaline content is less than 3%, the wastewater will be neutralized. It's because of the low recovery value of this wastewater. They will be neutralized to the point where the pH value meets the standard for wastewater discharge. And why should we neutralize this water? If a large number of wastewater discharge into the water, it will change the pH value and adversely affect aquatic organisms. And if this water is discharged into urban pipelines, acid and alkaline can corrode the pipelines. The widely used of neutralization method is use medicaments, and the neutralizing agent for acid is limestone, sodium hydroxide, and sodium bicarbonate. And for the alkaline, it's hydrochloric acid and sulfuric acid. And there are also other methods like mutual neutralization and filtration neutralization.